Now we'll see the analog of Newton's second law of motion for pure rotation. As we know from Newton's law of motion, summation of all forces is equal to F. Summation of F equal to m mass time acceleration about the center of mass. So this is the law of motion of linear motion. Now its analog means its equivalent for rotational motion is summation of tau c. Tau c means torque about the center of mass, and I that will be equal to I into alpha. I means moment of inertia and alpha equal to angular acceleration. So this is the rotational equivalent for Newton's second law of motion. Now we'll derive this equation. As we know, F equal to ma, and again A equal to R alpha. So we can write F equal to ma equal to mr alpha. Now we'll find what is torque. For torque equation, torque equal to F into R. So this was our equation number 1, and this is our equation number 2. If we put the value of F from equation number 1 to our equation number 2, then it will become tau, or torque about the axis, is equal to mr alpha multiplied by R, or it can be written in the form of mr square into alpha. But mr square can be written as the moment of inertia for a particle. So we can substitute the value of mr square by I instead of in the equation number 2. So we can write tau equal to mr square alpha, but mr square equal to, this is nothing but I, so we can write tau equal to I alpha, or more simply we can write the torque equation as torque about an axis equal to I about an axis about the axis of rotation multiplied by alpha about the axis of rotation in the sense of alpha, in the sense of tau. So this is our complete rotational analog for Newton's second law of motion. Now here is one question: why torque equation is more complicated than force equation? Now torque equation is more complicated than force equation. But why? The reasons are given below. For linear motion, force has an absolute value, whereas moment of inertia, tau means torque, depends on the axis of rotation, which don't have any absolute value. And second reason is mass has an absolute value. Absolute value, but moment of inertia has infinite values, or it or moment of inertia depends on the axis of rotation. That's why torque equation is more complicated than force equation. Next, this torque equation is applicable only in 2 points. Torque equation is applicable only on 2 points. First one is about the center of mass of the body, and second one is about a fixed line by which the body rotates. This axis is called axis of rotation, or instantaneous axis of rotation.